Thank you, madam, for lovely introduction. Good morning, one and all. Again, I am also thankful to you all to give me the opportunity to present my technical concepts in this webinar. And hopefully it will be very much useful to especially those who are in the research domain. They will find some good topics which they can carry further in especially in the wireless communication. And my major target is vehicular networks because as I specified in my title, I am working on intelligent mobility, and major concern is the wireless ad hoc networks. So hopefully it will be useful to research community. Okay. So thank you so much for giving me this opportunity, and I'm starting my screen share again. I hope my slide is visible.
Yes, madam. Yes, madam.
Yes, madam.
It's visible.
Thank you. Thank you, madam. So, good morning again, dear participants and the faculty members who joined in this webinar. As I specified in the title, I'm going to discuss something on beyond 5G communications enabling intelligent mobility. Now, of course, 5G is enabling the mobility, but the special word intelligent mobility is quite meaningful over here because people are working towards 6G, people are working towards lot of technical development so that anywhere, anytime communication can be more intelligent, smart and meaningful in this particular direction. Okay, so let us have the discussion in this direction, and I hope you might have some questions and queries. You may write in the chat box, so I will address your queries later. Now, the vision is we have to provide the solutions towards the intelligent mobility. We have to find out the ways to achieve this and to provide the mobility as a trustworthy and reliable internet services. Now, of course, whatever services we are getting in the present scenario, at the bottom level, the various radio access technologies or various wireless technologies might be used in a particular local domain. But looking in a broad sense, it becomes the internet services. I mean, IP-based services. Okay. We are going to continue the same scenario. We are not throwing our older protocols or older TCP/IP communication scenario, but still we want some advancement in the same direction. So for that, we can discuss some of the aspects for the present scenario and the future scenario associated with reference to the present scenario. So here a few statements are written. I hope my screen is clearly visible because I try to use the bigger fonts so that everyone can go through it. And later I can share this PPT also because dedicatedly I prepared it for you only. So the first scenario is increasing urbanization. So we can say that in future, more than 85% developed world's population will be in the a small number of ever growing cities. Means urbanization will increase. The density of people living in the city will also increase, and most of the people migrate towards the developed cities. Okay, so within such cities, the reliable high rate wireless communication, that will be the key requirement. Okay, and of course, this requirement will increase towards the transportation networks. Public and private transportation networks means you will have lot of solutions requirement, so that when the people are traveling, yeah, people are moving not only in the land mobile communication or terrestrial, but non-terrestrial communication also will be very much important in that particular era, especially when the networks of drones are there, yeah, networks of very low earth orbit satellite communications are there, or whatever, like, I mean, we will see the scenario gradually. Wireless connectivity everywhere. Of course, it is almost we are in that particular era, but still looking to the terrestrial and non-terrestrial, the global connectivity in a mobility will be our goal. Functioning of such a society in motion should be again supported by the intelligent mobility, where each connected transportation vehicle, that is car, train, bus, ship, aircraft, motorcycle, bicycle, everything, I mean, whatever is a moving vehicle is expected to be a smart object which is equipped with a powerful multi-sensor platform. Now, at present we are learning so many different subjects in a scattered way. Like we have the idea about the machine learning and artificial intelligence. We have the idea about the sensor networks, IoT implementation. We have the idea about the ad hoc networks. People have started working on the traffic pattern analysis, use of statistical cellular planning. People have worked on the vehicular channel modeling. So many things are there. We have also started with the controller area network in the automobile, I mean the cars and all. So the things are in research form, or at least up to certain extent we have achieved so many things. But now looking to the application, we are going to combine or integrate all these concepts in one particular system, isn't it? That is our goal. You will find the importance of all these subjects on a common platform when you at the end of this particular talk. Okay, so when all these support systems are integrated on a particular platform, it becomes the intelligent communication. And that what we want. Intelligent communication capabilities are required for the intelligent mobility based systems. Smart computing units are required. Internet protocol based connectivity is required. Okay. And that is also in various vehicular and transportation applications. Up to certain extent, we have already entered in that particular era. We are actually not in India, but most of the other countries have started the 5G services, and 5G phones are also available. So up to significant extent, 5G is in existence. Okay, but still the betterment is required. Whatever is targeted up to that level, we might not have achieved. So still it is the, it's a fuzzy domain always. You cannot say that we have entered in 5G completely, or the transition from one generation to other generation is also quite fuzzy, you can say, because all the targeted applications, yeah, all the targeted functionality at the targeted bit rate might or might not be achieved at any point of time. Okay. Also, we require the more pervasive and ubiquitous communications and the networking core, not restricting the existing research on 5G. But also it enables the future mobile communications. So that will employ the new concepts such as data analytics, artificial intelligence, machine learning, cloud computing, etc. Okay, so looking to the present and future scenario, the various issues to be addressed now at this level. Indirectly, you can say that this is a list of research opportunities which you may take up further. Okay, so I'm just reading it. Gradually, you will understand all the aspects during the discussion of this presentation. So first of all, I am not going to discuss the previous generations. 1G to 4G, I think most of you are aware with that. So let us start with understanding 5G and new protocol developments beyond 5G. Then, of course, when you have the idea about 4G, from 4G to 5G, most of the heterogeneous developments have started in the networking architecture. So just for continuity of the discussion, we will go for heterogeneous networks and distributed antenna systems. Then the use of millimeter wave, sub-millimeter wave and terahertz communication, which is a very, very important aspect. And I think this topic is to be covered in detail in this webinar. I think I have gone through some of the titles. So this is very, very important aspect as far as the intelligent mobility is concerned. Then the MIMO and massive MIMO is also very much useful for intelligent transportation systems. Because ultimately all these technologies are forming the basis to interconnect the moving vehicles. Okay, whatever may be the vehicle, it's a car or others, but still this is required. Of course, the conventional concept modeling, they are not suitable now because my channel is dynamic. Few years back, we were talking about the relay channel and Russian channel and Nakagami channel, where delay spreads were more important. Multipath fading was more important. But now we have to focus about the 3D channel model or more of the Doppler effects are to be considered. So you need the latest propagation channel measurement and modeling tools for connected cars, trains, ships, aircrafts, okay, and especially at the new frequency bands. Because frequently you will be coming across the NR, word NR. NR is a new radio spectrum, which is defined for 5G and beyond. And very soon we will see that now more focus is towards the millimeter wave communication rather than the lower frequencies. And how and for which particular applications this focus is there, that also we will see. Because resource handling is always a key part and our resource is nothing but the frequency, okay, and the bandwidths. So maximum spectrum utilization at the given radio frequencies is also very, very important aspect, which will lead to the intelligent mobility. Then integrated space, air, vehicle, ground networks. You have to combine everything in a global way, whether you are considering or dealing with the vehicles on land or vehicle in the sky, okay, or in the space. So this approach is, I mean, we are developing in this direction. Then integration of artificial intelligence and machine learning into new wireless systems, solutions and applications for intelligent mobility. Now, when there is a physical layer, you may include the artificial intelligence. When there is a big data handling, you can add the artificial intelligence. When there is a pattern based protocol handling, then also you can use the artificial intelligence. So you have various approaches by which you can incorporate, I mean, at the various levels, either at the physical level or at the other protocol layers, you can add the artificial intelligence to make so and so application smart. Okay. And the word smart comes thereafter. Then data analytics for intelligent transportation systems. Of course, data analytics is gaining the importance. Big data handling is gaining the importance nowadays because lot of decision making you can have on the basis of available data or the past, isn't it? At any point of time, when you have sufficient information available, you can take the intelligent decision making. And of course, for the data analytics, you can have the systematic methodology by which you can have the instantaneous decision making. And that helps a lot for real-time solutions for such intelligent transportation systems. Then the cloud and edge-based high performance computing techniques for mobile networks. So this is also very much important rather than individual resources. If you use the common resources for the decision making, it always gives you the best decision making in the high performance computing. Radio technologies for high mobility transportations are very, very important. Physical layer techniques. Now, again, we will, this subject is so vast and it is very, very tough to cover each and every smallest aspect in a particular domain which I am specifying over here. The list is too big and each and every aspect is difficult to cover. So, but I tried to highlight the important things so that you can work in that direction and you can uh, gain the knowledge in that particular direction. So, in the physical layer also, I mean, up to 4G, we were not so rigid about the physical layer because OFDM was the big solution to many wireless channel issues. And when OFDM came up, we were so happy that, oh, now ISI free communication, ICI free communication is achievable. But now, OFDM is also not sufficient. People have done lot of modifications in the basic OFDM by incorporating filter-based multi-carrier GFDM solutions or index modulation based OFDM, means modulation mapping schemes are varied. So lot of moderations are made in the basic OFDM to achieve the various possible solutions from the physical layer itself. Then wireless wireless technologies for automated and connected vehicles. Actually, this point can be further improved by adding the word various wireless radio access technologies. Like, we have number of existing wireless technologies. We have Wi-Fi, Bluetooth, we have Zigbee, we have WiMAX, of course, is not so popular. We have LTE. So we are not going to throw all the older technologies, but we are actually targeting this wireless technologies to be part of our system and to be used in a very intelligent way, so that all these techniques will support in the development of intelligent mobility. Okay, and as I told you, physical layer technologies or techniques are, of course, the novel physical layer waveforms and modulation schemes. So these things are to be addressed now if we want to move further towards the intelligent mobility, of course, beyond 5G. 5G is supporting VANET, but we are thinking little ahead. Now, I told you earlier that I am not going to discuss more about the initial generations because they were so simple, and we all are, because we are working in the wireless domain since long. We are acquainted with all the fundamentals of 1G to 4G. But if we go for further scenario, so you can put the modified titles like this. Earlier, just reading the titles, 1G was the foundation of mobile telephony. 2G was mobile telephony for everyone. Then the foundation of mobile broadband enhanced in 4G. Then embracing a network society, and 5G plus is enabling a smart, sustainable society. So just see, this figure is so nice, so well developed, that gives you the idea about the key aspects of each of the generation, and year-wise scenario is presented. So focusing on the 5G and 5G plus, um, you know, the targeted bitrate is 10 Gbps, and in 5G plus it is 1 Tbps. And fifth generation wireless network will increase the 1,000 times capacity. All of you know that bits per second. Okay, channel capacity, and indirectly it defines the spectrum efficiency, bits per second per hertz. So whatever bandwidth or radio resources are available, they are sufficiently high, and it supports for 100 plus billion connections and less than 1 millisecond latency. That is there in 5G. I mean, we have already crossed 2020. So most of the foreign countries have adopted 5G, and they have already achieved this particular scenario. But if we think 2030 and beyond, our more focus or extension to millimeter wave frequencies, distributed massive MIMO, and real-time cloud computing. These are the major aspects. And of course, this particular aspects, when we achieve, will not only provide the smart communication, but also the intelligent mobile communication at the bitrate of 1 Tbps. Now, the figure which is presented over here, you might have seen this figure, and the figure goes on extending to the various scenario. This is the heterogeneous architecture, and it covers the WiMAX eNode B data centers, satellite receivers, device to device communication, then the Wi-Fi community, then the various control signals with reference to long-term evolution, cognitive environment, vehicular network, then the Ethernet, massive communication, sensor networks, and all. So, we are going to work with various wireless technologies together, interworking of these technologies, and the heterogeneous architecture means it's very, very complex scenario in which we have to work. And still we don't want to throw the backward compatibilities, okay, up to certain extent. So, this gives you the idea about the existing heterogeneous architecture, and this architecture is going to grow in future. When we talk about 5G plus, this is existing, almost existing version, you can say, and this version is going to be extended in future because, as I told you, you are going to add the artificial intelligence, you are going to add a few new protocols, okay, which are useful for now. Here LTE-A, E node B is shown. Now LTE-A or LTE Advanced is not sufficient. We will see very soon that in LTE also lot of protocol development and advancement is made, and you will find the new versions of LTE. Clear? So you will have the extension to this particular heterogeneous architecture in near future. Now, as I told you, always I will start with reference to 5G and the beyond requirements. So if we know the existing scenario, if we understand the existing scenario, we can think one step ahead in this particular direction. So this is a good figure, is released by European Commission, and it's very simple. I mean, I could have listed out all these things, but in pictorial form, it is better to understand. So smart wearables, smart good water quality testing, smart mobility, smart parking, car to car communication, utility management, then the connected houses, then intelligent domestic applications in a wireless way, traffic priority, e-health, entertainment, smart grids, security and surveillance. All these things we have already achieved. Okay, but now, in this particular figure, some of the aspects are on a static basis. Like suppose you go for smart grids, entertainment and all, the mobility aspects are not e-health. Means the things which are not related to mobility, they are already achieved and people are still making it more sophisticated. But as far as the mobility and the mobile aspects are concerned, still there are so many open challenges and need lot of development in that particular direction. Unless we have this developments, it's very, very difficult. Up to certain extent, the mobile vehicle will provide you the internet connectivity that we are already using. We are using the internet services in the while driving the car and all. So up to certain extent, the things are there, but then so many other aspects we are targeting in future, especially in the automobile industry and the aircraft planes and all, where the smart vehicular communications are expected. So still further improvement is required. So in what sense, that we are going to discuss. Now in the present scenario itself, we require three major types of applications. If I bifurcate this particular scenario, we have three different categories. One is massive Internet of Things, mission critical control, and enhanced mobile broadband. So with all three colors, the requirements are highlighted with blue color, with purple color, and with the sea green color. So for massive Internet of Things, we need deep coverage, ultra low energy, ultra low complexity, ultra high density. For enhanced broadband, we need extreme capacity, extreme data rates, deep awareness. For mission critical control, we need strong securities. I'm going to give you the few examples in a pictorial form. so that you be acquainted with the present requirements and which can be drawn to the future requirements. So ultra high reliability, ultra low latency, extreme user mobility, etc. Because mission critical control is a real time requirement. This is high capacity requirement, and this is the intelligence or the smart sensing requirement. So all these three you are merging in one particular heterogeneous scenario, and we are achieving the various targets by combining these applications in a very smart or intelligent way. Now, for achieving this particular scenario, we have 5G new radio spectrum. We will see the new radio spectrum and the range of frequencies also. So it needs flexibility, reliability, low latency, and high throughput. Okay, how the detailing is given in the figure itself. At the same time, low power wide area networks and the existing 3G, 4G, 5G, and ZigBee protocols, they are actually interworking, overlapped. So it needs many other scenarios to be covered, like geographical coverage, range, power consumption, bandwidth, radio chipset cost, subscription cost, number of base station, transmission latency. So all these things we have to consider together, and we can find out the best possible solution. So this is enhancing mobile broadband few pictorial scenario. Of course, up to great extent it is achieved with the start of 5G scenario, but still you cannot say that it is fully achieved. So 3D or ultra high density video telepresence, this is enhancing mobile broadband. It means very high bitrate communication. This is tactile internet, some touch base. Okay. Then the ultra high density video streaming, demanding condition like venues. This is a stadium and the live telecast of a match might be there. Then the broadband fiber to home and the virtual reality or augmented reality. These are the high bitrate applications where we require multi gigabits per second and uh, minimum latency and uniform experience. Means there should not be any differentiation among the users. Of course, these are not the you can say mobile applications, but of course this can be considered when you are in mobility. Then the mission critical control or control services. So autonomous vehicle, this will be our major focus now onwards, because we are going to focus on the VANETs. Then the robotic application, energy and smart grid, industrial automation using robots, aviation, especially the drone network is a very important aspect for intelligent mobile networks. Drone networks are also gaining huge focus, which is again can be considered as beyond 5G, and the medical applications. So here, when the mission critical means the things are moving, and within a fraction of time, your correct decision making should be there. Otherwise, you will come to an accident, and your control may not be considered as a good one. So high reliability, extremely low loss rate, very low or ultra low latency, and high availability. Means it should not be a failure tolerant. Okay. So mission critical is our goal actually. Mission critical services, especially when the vehicles are in movement. And the massive internet of things. Of course, when you have the mission critical services, the massive IT and broadband services both will help. So you cannot differentiate that, okay, I need only the vehicular aspects, so other aspects are not so much important for me. It's not like that. all the things will work together and one integrated system will work rather than the individual component of that particular system. So smart cities, smart homes, utility metering, wearables, remote sensors, actuators, object tracking, everything. These are all, I mean, you may find hundreds of such applications in the IoT base, and which is already started, and people have already started working in this particular direction and achieved so many things. So now after looking to the scenario, architecture and the requirements of the systems, let us focus on the resources. So the key resource is the spectrum. So we can start with the key spectrum which enables the 5G scenario. Now all of you know that up to LTE and LTE Advanced, we had the restricted bandwidth, frequencies, license frequencies to 2200 megahertz around. But when the 5G is launched, the new radio spectrum is also introduced along with, and you can see over here that this range starts from somewhere below 1 gigahertz range up to 100 gigahertz, extended up to 100 gigahertz. And we have seen the various applications over here. Have massive Internet of Things, mission critical control, and enhanced mobile broadband. Now, based on these applications, we can have the clear-cut distinctions in the use of the available NR. So when you go for lower frequency ranges, below 6 gigahertz, if we see mostly. So low band and mid band, if we see, you can see over here 2.4 gigahertz, very popular band. Most of the Wi-Fi and other applications like unlicensed range applications are working in this field, and it is for both outdoor and indoor applications. 5 gigahertz is also unlicensed bandwidth, and this is also for both the applications. Then automatic frequency control, standard power frequency ranges are there. So around 6 gigahertz range. So these are all the application frequency ranges, unlicensed ranges for Wi-Fi and 5G, but for majorly in the IoT applications. Okay. Below 1 gigahertz, most of the applications are for massive IoTs. 1 gigahertz to 6 gigahertz, they are wider bandwidths for enhancing mobile broadband and mission critical applications also. And above 6 gigahertz, that is the millimeter wave, they are the extreme bandwidths. Shorter range for extreme mobile broadband means it provides the high bitrate communication. Plus, you will find that in the mobility based applications also it plays very important role. Now, this is not the clear-cut distinction. It is just the rough idea that how the frequency ranges are distributed. So, license spectrums are the cleared spectrums for exclusive use by the users who are purchasing it or providing or getting the services from the service providers. Shared license spectrums are the complementary licensing, and it is for the shared exclusive use. And all unlicensed are multiple technologies for the shared use like Wi-Fi and all, or in some of the IoT applications also it is. Now shared license, I should explain little bit. Shared license is the concept in which the primary user and the secondary users are nominated to use the particular shared license spectrum. Primary user is the owner, but when this owner is not utilizing that particular spectrum, the secondary user can claim that particular spectrum for a temporary use. So I'm not going in the detail of that particular concept, but you can find it out that this is already started from LTE and it is now extended to cognitive radios also. So actually, if I consider all these frequency ranges, it supports diverse network topologies from device to device to the mesh networks. Okay, so these ranges are appropriately distributed to the various applications. Now, the very, very important change in the 5G scenario is, which is actually very appreciable, you can say. Up to 3G, you had separate voice and packet, the circuit switch and packet switch services. But from 4G onwards, everything has become packet switched only. And thereafter, in 5G, flat IP architecture is created. It means whatever may be your radio access network or technology, maybe GSM, GPRS, UMTS, LTE, WiMAX, all the technologies, of course, as I told you, they are not thrown totally. Of course, now the GSM users are decreasing to a significant extent. Even 3G users are also reducing. But still, we are not throwing it out. So there is one aggregator which converts the radio access technologies into the flat IP network, and then the smart nanotechnologies are used and the cloud computing that provides the various global services like search engine, defense, astronomy, transportation, communication, medical health, education, government, private portals, public portals, and the banking sector. Important global service providers are listed out over here. So my concern is my conventional way of data transfer is now not suitable. So 5G onwards, this is a big transformation in the system. The switching approach, you can say. So flat IP architecture, just have the overview of it so that you can keep it in mind that how the previous scenario and present scenario is different, and that leads to the intelligent system development. So this is a generic architecture which is adopted in 5G, and 5G uses the flat IP concept so that different radio access networks can use the same single nano core for communication. Now from this particular figures, you can say that all the domains of electronics have become so important nowadays. Whether it's a nanotechnology, it is a networking aspect, it is the machine learning aspect, everything is becoming important. And the wireless technologies and all. So radio access networks supported by 5G architecture, as I read, GSM, GPRS, etc. And the flat IP architecture identifies the devices using the symbolic names, unlike the hierarchical architecture. Means, it's like mapping into the flat IP architecture. And nano core is the heart of the system, and nano core actually consists of all IP architecture, cloud computing scenario, and the nanotechnology. So that makes the smart infrastructure in this particular scenario. Now, especially when I want to go for intelligent mobility, we have seen over here the various spectrums I have shown. Above 6 gigahertz, it's the millimeter wave, and below that is the existing radio access technologies and the massive Internet of Things and all, and the enhanced mobile broadband services. So if we go for intelligent mobility, my millimeter wave spectrum becomes very, very important. Actually, you can see over here below 6 gigahertz, some IMT bands and the existing services are shown. But beyond that, the license and unlicensed distributions are also defined, and this is called gigabit LTE and beyond. And this is actually mobilizing the millimeter wave. For vehicular applications, you can use this particular ranges. The various ranges are specified over here. 20, 30, 40, 50, 60 and 70 to 80 gigahertz. Actually, as I told you, it is extended up to 100 gigahertz. So still some finalization is going on, but some of the ranges are identified, and you can say that for various applications, various license ranges are defined. 60 gigahertz around is the unlicensed range, and 70 to 80 gigahertz is the minimal license range. So the various applications are under the development. Okay. So actually, I have highlighted this figure just to show that you have some impact, increasing the bandwidth and decreasing the range. Actually, it is cutting, the figure is cutting a little bit. And you know, this is the major portion which is of interest of our intelligent mobility. Especially, as I told you that a lot of urbanization is to be done and the cities are going to be densed. So in that scenario, this particular communication range of frequencies will be very much useful. Now, as I told you, I won't talk much about the previous generations because otherwise we cannot move further. We cannot develop our vision. So up to 2019-20 approximately, our 5G protocols were already developed, and release 15 and 16 was also available. Currently, the release 17, 18 is also made available. That is 5G SEVO. SEVO is the short-term evolution. These are extensions to LTE. Short-term evolution, medium-term evolution, and the long-term evolution. And the long-term evolution will be, I mean, it's a question mark. Can it be considered as 6G? Still answer is not given, but people are actually imagining as the 6th generation transformation. And that is targeted up to 2030. Okay, you can see the years of developments, years of various releases by 3GPP. I hope all of you are aware with the releases. Third generation partnership program has started the development of 3G, the UMTS, somewhere around 1995. And from there onwards, they have developed the 3G UMTS scenario, and then the third generation partnership program 2, 3GPP2 has given the releases. Releases are nothing but the standards or the written document of set of protocols, and the amendments are also frequently publicized by 3GPP. So 3GPP2 has given the LTE and LTE advanced somewhere around 2014-15, and thereafter they have started with the 5G scenario. Okay, so release 15, release 16 and all. So I think this figure is very clear that what is targeted or addressed in a particular release. So 5G NR license and unlicensed range is its use is specified in release 15 and 16 with less than 52.6 gigahertz, where LAN and non-private network concepts are also introduced. New radio based V2X. V2 means vehicle to everything. We will see these things in detail. Then URLLC enhancements and non-private network and new radio light is introduced. Okay. Then in release 17 and 18, the 5G NR more than 52.6 gigahertz and less than 250 gigahertz is its use is introduced. Non-private and NR light extensions, IAB enhancements, non-terrestrial network, radio access network, data collection, and artificial intelligence and machine learning enablement. These are the things which are addressed in the new releases. Then similarly, release 19 and 20. They have added the flying user equipments. Flying means in the aeroplanes and all. Cells and relays. Relays are also not fixed, non-static. Relays, I think all of you are aware, when the heterogeneous environment is developed, you may have femtocells, picocells, macrocells, microcells, etc. And when the mobile user is at the boundary of the macro cells or any of the cells, by using relay, you can have the range extension. Okay. So these things are already addressed in this various releases, wireless fusion with AI/ML and C plane and user plane upper layers. Now C and user plane will be defined soon. These are the planes, control planes and user planes in coordinated multi-point scenario. They are defined in coordinated multi-point scenario. So this you can show. Okay. I will show it later in the figure. Now, for releases 21, 22, 23, 500 gigahertz to 1 terahertz range of capacity is expected. Battery-less devices, network providings. Now, one thing I would like to highlight at this point. People are working in the direction of wireless power transfer also. I mean, suppose you have IoT implementation, yeah, if you have the radiation of power, we all know that law of conservation of energy exists. So if you identify some ways, suppose our battery is drained and some immediate decision is to be taken and that node is not working properly. So somehow you can activate the wireless power transfer mode and from the surrounding available energy sources, you can charge your battery up to certain extent and you can do that task. नहीं तो फिर ऐसा होगा जब when the critical environment is critical decision making is required, at that moment your device may not work properly. So it is energy harvesting and energy efficient green solutions are also, very much expected in this particular direction. Again, the wireless fusion with AI/ML and every plane and every layer of stack, including physical layers, should be working in the, of course, in the cross-layer architecture itself. Integration and of communication, sensing, imaging, and radar, cognitive integrated access across heterogeneous technologies like new radio, Wi-Fi, Li-Fi, etc. So these are all the developments and targets. We are in 22. So up to 22, the things are available. Other things are in progress. So releases we will get very soon. And, people have already started working in this particular direction. So all those things which I have highlighted in the previous scenario is presented in detail in this particular figure. So it's time consuming, so I'm skipping this figure. I will share this PPT with you so you can go through it later. These are all the key performance indicators. These are the key performance indicators for the NR, NR Sevo, NR Mevo, and Levo. So as I told you, short-term evolution, medium-term evolution, and long-term evolution. So these are all extensions to LTE scenario only. But the performance indicators are also targeted. So as I told you, initially we have seen the architectural requirement, then we have seen the resource requirement, and then we have seen that how the protocol developments are made to reach to the requirements or the expectations from 5G and beyond. Now, all these are forming the basis for my intelligent mobility system. Okay. So data rate up to several Gbps details are given in the table. End-to-end latency requirement, I mean, less than 500 millisecond. Time synchronicity is required less than 1 microsecond down. Means it should be perfectly synchronized. You can reliability. Okay. So all these things are expected or targeted from the short, medium, and long-term evolution of 5G new radio. And as I told you, you can see this timeline, how they are developed. And these are Sevo, Mevo, and Levo trends. Actually, top 10 are mentioned, but I thought that two are not so much useful and are not coverable in this particular, so I skipped it. But still, you can find out or identify the top 10 trends which are making it possible. Trends are nothing but the technology highlights. These are the parameters which are targeted, and these are the supportive technologies. Like millimeter wave frequency is the main candidate. So in Sevo, 52.5 to 250 gigahertz, then 250 to 500 and 500 to 1 terahertz. Then the massive MIMO, in Sevo up to 500 to 512 elements. Then in Mevo it is 1024, and it is thousands of elements in the Levo. Then the enhancement to support low latency and good synchronization. So that is required in Sevo and Mevo, the efficient waveform and modulation techniques and the cognitive selection of advanced modulation waveform. Then the unlicensed multi-connectivity and the cognitive approaches are targeted in the 3 different types of systems. Of course, all 3 are yet to achieve. I mean, they are just the steps of progresses, and these are all the actually at present you can consider it as the vision only. Means we are targeting these things, and of course work has already been started and many papers are presented in this particular direction. So this is a research phase which we are discussing. Then as I told you, IAB system is targeted, integrated access and backhauling. So that is to be enhanced. Then in-band full duplexing for G node B and some user equipment category, and the cognitive dynamic duplexity and carrier aggregation is targeted at the level. Then other points are also there. Support of non-terrestrial network, integration of terrestrial and non-terrestrial network, and the support of massive VLU. Actually, I have shown both the figures along with. massive MIMO, you have the idea that it's the array of antenna, not 2, 3, or 4 or 8 antennas, but they are hundreds of antennas. And as I shown over here, later on the thousands of antennas are to be targeted for having the high spectrum efficiencies. So here actually two typical cells are shown. One is a macro cell, one is a micro cell. And large antenna arrays to increase the cell throughput is shown over here, and where the dozens of devices can be. Now this is actually playing the role of radio access as well. Okay. If you have a massive MIMO with adaptive beam forming techniques, indirectly you can have the radio access available or achievable with this. Conventionally, we had the radio access technologies like frequency division multiplexing and time division multiple access technologies I'm discussing, then the CDMA, then the OFDMA. But you know, when such a high scale applications are targeted, our conventional radio access technologies will not be working. How can you work with carriers, hence multiple access? That can be operative at the small scale ad hoc network, say Wi-Fi based ad hoc and so. But when you have such a large scale systems and such a, I mean, millions of devices with a huge number of users, it's very, very difficult to go for FDMA and TDMA and CDMA. So you need good radio access technologies, and the massive MIMO with adaptive beam forming is shown over here. Actually, this bi-directional full duplex communication links are showing the adaptive beam forming. Similarly, you can have 5G network through gateway and feeder link. You can communicate to the LEO satellite systems and the other different devices or the users who might be flying. Okay, so satellite field of view is shown with VLEO. So this is the scenario what we want actually to achieve. Okay, and again this is the figure from Qualcomm, and it shows the importance of millimeter wave technology with massive MIMO and the adaptive beam forming together. Okay, so the first figure shows the millimeter wave G node B, then the millimeter wave repeaters and millimeter wave integrated access and backhauling. Okay, now I think all of you are aware with the terminologies. What is G node B, what is repeater, and what is IAB. I actually explained little bit about the relay. Repeaters are nothing but the relays, and IAB is the integrated access and backhauling. So it's a specific node which is showing this kind of scenario, which I have shown in the massive MIMO. Means it provides you the reduced cell interference and a hierarchy. Now, G node B is actually the base station only, but the different names are given. As you know, when we started with the GSM, we were calling it a base station. Then when we started with UMTS, 3GPP has given the name to the base station, that is node B. When the LTE started, it was called E node B, okay, because it was a long-term evolution. So E node B. And when the 5G started, people called it G node B. So it's the base station only, but with, of course, extra capabilities, in which, you know, here this particular version is showing the use of new radio spectrum with millimeter wave and handling the remote radio heads RRH. And you know, there is a fiber front haul is also there, and the wireless front haul is also there. So both the communication scenario is made available for the reliable communications, and repeaters are just to extend the coverage ranges, and they are of course smart repeaters. Okay, and these repeaters are also shown with the adaptive multi-beam operation and time division duplexity awareness. So there is a simple repeater, you can see over here, without intelligence, and this is a smart repeater. Okay, so of course below all these figures some comments are made. Here the beam overlap with the improved angular diversity. Here flexible spectral reuse from single millimeter wave cell. It's a reuse only. Okay, and this is range extension and coverage around the blockages. So you can improve the coverage and capacity by incorporating this kind of IAB nodes. Okay, integrated access and backhauling, by creating a lower level hierarchy below it. Is just like this, as I have shown. This is the massive MIMO with capacity. This is the reduced capacity for the smaller area. So this kind of arrangements you can make, and you can have the smarter solutions in this. Now, more focusing towards the mobility technology only. Now, whatever we discussed, all those things are forming the basis for our system requirement. We have seen so many applications possible, isn't it? Now, out of this, all the vehicular applications, now if we focus, then the scenario created is like this. Now, we will see few points over here. These scenario cannot be achieved by single entity or single body, because we need the development of the vehicular ad hoc networks. We need the development, similar developments in the automobile industries, and the computer engineers will develop the VANET protocols. Electronics engineers will develop the physical layer waveforms, channel models for the testing purpose. Artificial intelligence is also required, and the automobile industry support as well is required. Unless you join hands from the different perspectives, you won't be able to achieve the particular reliable system. Now, here one scenario is shown for the vehicular network. So vehicle to vehicle communication, intra-vehicle communication, vehicle to broadband cloud communication, vehicle to road infrastructure communication, all are required. And that's why a general word is used, V2X, vehicle to everything. That is vehicle to infrastructure, vehicle to network, vehicle to vehicle, vehicle to pedestrian, vehicle to device. All the communications are required, and that also with the artificial intelligence, machine learning, and the smart solutions and planning. Okay, all those things are required together. And at the same time, as I told earlier, automobile industry support is also required. So actually, in present scenario, even automobile industry is also working on a ACES concept. A is automatic autonomous driving, C is connectivity, E is electrification, means electric vehicles, and S is the shared mobility. So almost all the vehicles. Now this is just I'm showing for cars. Similarly, the other form of vehicles might be developed in the same way. Even in the flight controls also, lot of intelligence might be added. So it's very, very difficult for me to cover each and every aspect. for intelligent mobility, but most of us are car users. So let us focus on it. And VANET is a quite important topic in the present scenario. So actually this figure I have taken from some other language reference. So I'm not able to interpret this too, but other things are very easy to understand, that this is the growth, and compared to 5G, 6G requires smartness and green solutions. All other things are same. बाकी आप देखो compare करो, and the smarter phones are developed accordingly. So these are all the research challenges in beyond 5G moving networks, mobile networks. Okay, means especially vehicular part, we can say, and the cars are shown over here as a major part of it. So every node is mobile. Caching and computing and edge cloud computing is required. Security and privacy should be maintained. Monetization and business should be, it should be grown with this. Power consumption optimization, multi-connectivity, multi-radio access and resources, and higher directionality at millimeter wave. We have gone through all these aspects in our previous discussion. And car and drone, these two are shown over here. It means you need the terrestrial as well as non-terrestrial, that is the sky or space-based communication as well. And drone is not a too high level flying component, you can say. So some sort of intelligent control is possible with the drone-based solutions as well. Okay. Of course, drone is a power-hungry device. It should be governed properly by providing the energy sources appropriately. So many other issues are there, but still you can find out the solutions for that and can make this particular system intelligent. So this figure is very, very important for us. These are all the challenges beyond 5G intelligent mobility networks. Okay. Now, next, let us move towards the realization part of VANET. So, of course, challenges are there, other supports we require. We need the infrastructural support. We need the, the surrounding supports. Suppose we want to go establish the VANET, so we must go for roadside units. RSUs are to be developed. Okay, then and then only inter-vehicular or vehicle to roadside or inter-roadside communication can be possible. So all those things are required. Even GPS support is also required. Connectivity, drone is not shown over here, but I think that also you can consider. So then again, just as a top-down approach or just as a reverse engineering, looking to the scenario and looking to the availability and looking to the expectations, we can develop the architecture of our vehicular ad hoc network. Okay. So this is very simple version of it. Detailed version you can find from the net. So you need the external information, first of all, like GPS navigation system, yeah, in-vehicle sensors. Because when the vehicular networks are to be developed, definitely lot of sensor support is required. You cannot do it without that. आपको instantaneous decision making करना है. Unless you have some feedback about the real present scenario, means your location or where you are, what is your speed, what is the surrounding status. Unless you know all these things, you cannot take the decision making. So the VANET architecture says that get the external info. Information connector provides this information to the various layers which are designed for the VANET architecture. Physical, single hop, multi hop, data services, and application protocol layer. Okay, and then the external management system is little faint, but is visible. So this is the way I have to develop my vanilla architecture. If I don't, then definitely accident is going to happen. Okay, so VANET. Now, one thing I would like to tell you, ad hoc network is the network which is connected on a fly. Okay, and it can be terminated as and when required. So that is our basic concept, fundamental concept. Now, vehicular ad hoc network, we can consider as a distributed scenario, and we can consider that, oh, whatever concepts of ad hoc networks are there, we can apply to the vehicular ad hoc network, because now difference is my device is in mobility. But that is not sufficient, because my vehicular, of course, whatever scenario is shown over here is the scenario of a city area. Okay, and whatever concepts and the speed of vehicle is to be considered over here is in the dense urban scenario only. When you want to apply these concepts to the suburban or the highways, definitely you need to apply some modifications in this. But this vehicular ad hoc network architecture is little beyond the conventional distributed ad hoc networks, because you need the vehicle to vehicle, vehicle to other vehicle, vehicle to roadside, even vehicle to network communications also. So it is little beyond the conventional concepts of the ad hoc network. Now, VANET is our requirement. As I told you, the various things are to be supported in order to have the implementation of the vehicular ad hoc network and the mobility management in the intelligent way. Then how the automobile industry works to support all these things. So at present, I am skipping the applications and services because that is their final outcome. But below that, what protocol layers they are following? Okay, so there are three important layers where electronic and computer engineers role is applied. So one is in vehicle, second is a roadside technology. You need to provide the supportive environment. If I have to make the autonomous, intelligent, smart car, I must put the sensor support. Okay, so sensors, local computing and operating system, even the in vehicle controller area network, yeah, CAN you might have heard, or internal sensor networks are also possible to develop in the car itself, and the actuators. So this support is required. Then you need the wireless point-to-point connectivities. Then the connectivity with the outside cellular and satellite systems for GPS connectivity requirement and all. Or even if the drone-based control is to be provided, then there also you need some sort of connectivity. It means you need the fundamental infrastructure, sensor networks, etc., and the wireless technologies. And then for the control and data management, you need OEM cloud kind of thing or the common cloud. OEM is a specific example over here because, next is OEM only. This is OEM is the Oracle Enterprise Manager Cloud Services. And this is the service especially provided for the moving vehicle based cloud management, OEM cloud. So if you read the details, it provides the device management services, device messaging services, okay, and smart energy management, SMS messaging, UDP messaging, then embedded device customization, then data management. You can go through it in detail. Mostly these are the services for the moving vehicles. So specifically, if you go through the details of OEM cloud services, it is for mobility handling in a smart way using the cloud. And the common cloud is a common resource, like whatever other cloud services you are using. So both these are required for text. It is a text tech challenges far beyond the connectivity. Automotive challenge means your automotive industry should also follow this protocols. Otherwise, the integration of our wireless technologies and the abilities of the moving vehicle may not match, and that they should keep in mind. Now, here are few points I have listed out. Uh, in addition to making the car itself more connected, stakeholders need to build roads and which are capable of supporting the car of the future. So infrastructure development is also required. If you have the sensors, okay, which tracks the white strips, so for that you must have the roads with white strips. If it sends the objects in between the in the middle of the road, definitely the proper objects for identification of different signs or other, whatever things are required, accordingly the road should be built. We envision a multitude of connected devices along the roadside, including cameras, monitor traffic situations, sensors to gauge the temperature, driving conditions, temporary roadwork signs, and so on. So deployment planning is required. Infrastructure planning, then deployment planning, then third is the cellular planning. All these devices will have to communicate with cars. As I told you, roadside units are required. Yeah, the other, cellular services are required so that vehicle to network connectivity and communications can be possible. So with cars as well as the central intelligent traffic management systems, this kind of communication links are to be established. And of course, not only the existing wireless technologies, but millimeter wave technologies, massive MIMO, adaptive beamforming, location-based services, and relays, all those concepts are equally applicable to have the vehicle to network connection and even the fiber connectivity and the reliable power sources. And I told you that power transfer mechanisms are also very, very important on gaining a lot of focus, because as I told you, now people are finding the green solutions. Green solutions matlab, power is already radiated. Use it in appropriate way to charge certain devices. And wireless power transfer mechanisms are very popular nowadays. So all those things are utilized to self-manage these devices. Many will rely on the wireless links and the battery power. So all those things are to be managed properly. Then fourth important part, the resource management. So your telecom operators, they have a very, very important role to play to build the networks with wide coverage, low energy requirements, and uh, it should be based on narrowband IoTs, NB IoTs. And CAT M1, category M1. Very soon I will tell you what is CAT M1. It is LTE CAT M1 for mobile services, okay, or the mobility based services. Then the low power wide area network cellular technology. So all those things and the use of new radio spectrum. These all things are to be provided by the telecom operator. Means आप अगर resources नहीं provide करोगे, licensed or unlicensed based services may not be provided, then all those things cannot be handled properly. And last is what's more, as a telecom operators, they should expand their capacity along with highways, means more coverage area, more better cellular planning. Many synergies should emerge in a sharing based infrastructure such as fiber optic communication and power networks and the civil work coordination. All those things are to be done simultaneously. So OEM I already introduced. Up to 4G, we were aware with the LTE, that is as a long-term evolution LTE network. But thereafter, 3GPP has given some changes, major changes at the physical layer and at the other protocol layers also. And then the various other versions of LTE have been formed. One is very popular version, which is now gaining lot of focus. That is LTE Cat M, category M. In that M1 and M2 are there, but M1 is gaining more popularity. And you can see over here, Cat NB1 is the narrowband IoT and the bitrate expected is 1 to 10 kbps. Sensors are mostly used in this frequency ranges. So the parking control, agricultural monitoring, industrial monitoring, pollution monitoring, lighting, HVAC control, smoke detection, etc. Now all these colors are shown in a fusion way. I mean, there is no clear cut boundary, but a rough estimated values are given. 100 kbps to 1 mbps is Cat M1. So all your mobiles or wearables and meters with little mobility are falling under the Cat M1 category. So fitness bands where the pedestrian movement is there, smartwatch, personal pet trackers, asset trackers, patient monitoring. Okay, so wearables and meters are in this particular. Then Cat 1 and Cat 4 are high bitrate services. Cat M and NB IoT try to complement each other as per the requirement, and Cat 1 and Cat 4 applications will also remain. Means you cannot throw it out. Okay. Timeline I will show you in what timeline they are developed. But Cat 1 and Cat 4 are the more aggregators and routers, network bridges, in-car infotainment. Information and entertainment is the connected word now in very popular IoT gateways and all, video surveillance. So these are falling under Cat 1 and Cat 4 category with the various bit rates. So these are all the cellular IoT and service provider support requirement. Now we can see it in detail. Actually, eMTC Cat M1 and NB-IoT Cat NB1, they exist in parallel. Okay, so LTE IoT applications are very, very important. I told you that when the vehicular ad hoc networks are developed, the sensor support is very, very important in this case, and its deployment also. And up to certain extent, if the tracking system follows this kind of protocols, you can see over here, some of the applications are shown. NB-IoT is for almost fixed delay tolerant IoT use cases, and other is the pedestrian or mobile IoT applications with VoLT and mobility support, you can say. So both are working together. Of course, you cannot draw a clear boundary that, oh, in this particular case, only eMTC Cat M1 is useful or this. NB1 is useful. But how they are developed, in what capacity they are developed, that is shown over here. LD is that what we are using today with downlink 10 Mbps, uplink 5 Mbps, 20 megahertz bandwidth, MIMO, full complexity, FDD, TDD support, and transmit power of 23 dBm. CAT M1 and NB1 are defined under release 13s. And you know, release 13 is the start of the 5G approximately. So in that scenario, the peak data rate of CAT M1 is 1 Mbps, uplink and downlink expected. Bandwidth is 1.4 megahertz. And here NB1 is very static application, low bitrate application, and low bandwidth application. So single receivers are used in both the cases. This supports LTE, CAT M1 supports half duplex FDD TDD with 20 dBm transmit power, and this CAT NB1 supports half duplex FDD only. So when you want the vehicular ad hoc network implementation, at least at the IoT level, you need some simplified versions of the sensor network establishment, or IoT establishment rather, not sensor network, IoT establishment with the proper systematic planning. Okay. So that what is shown over here. This is all about the LPWA technologies, this low power wide area network, and its detail and the supports from the standard organizations. These are showing the differences in the physical layers of LTE, CAT M1 and NB-IoT. You can see over here the physical resource blocks are different in both the cases of CAT M1 and NB-IoT. And if you see the LT physical resource block and the structure of OFDM, no, it is just the same, but size of the resource blocks are changed. And you know, this is in-band with LTE, and this is narrowband IoT in-band with LTE. How they are kept within the, I mean, the resource block organization is shown over here. Okay, is included over here, and the other resource blocks are included over here to set the multi-carrier scenario. I think it is 11.
Yes, madam.
And few of my slides are still pending, but I can conclude at any point of time if you wish, and I will share the PPT. These are the few radio access technologies and the options which are possible for vehicular requirements. So as I told you, new radio frequencies, various signal formats, even NOMA is gaining, non-orthogonal multiple access is gaining lot of popularity. Then, as I told you, heterogeneous radio access technologies, millimeter wave communication, coordinated multi-point. These are the various ways to have the radio access nowadays, positioning and beam forming, etc. And this is advancement beyond 5G. As I told you, terrestrial and non-terrestrial communication should be combined. My important topic was, another important topic was software-defined networking, but this I am skipping for now. And I'm sharing my PPT.
Madam,
Most of the information.
Madam,
Please.
yeah. As we are approaching the end of this session time, so you are requested to share your PPTs with our participants. We can share.
Yes, I will definitely share. And this is the last part of my PPT, software-defined networking. And I have given that architecture, that how it is useful in the vehicular ad hoc network development, SDN VANET, for having the intelligent mobility with intelligent networking support. definitely I'm going to share this PPTs. So I'm very much thankful for your patient listening. And if you have any query, you can ask me. Otherwise,
Any query, please, you may address. Yes.
yeah, I'm definitely going to share my PPT. You
Okay,
know,
one
this is a
query
very
from Dr.
wide.
Sunandita Debnath.
Yeah.
And there is one in chat box. There is one message also is there, ma'am. You can also see the message in the chat box.
Yeah,
Am I
yeah, yeah.
audible? Am I audible, ma'am?
Yes, yes, please.
Yeah, it is very nice to hear from you. I have just a little, I want a little focus from your side that as a wireless network engineer, what can be our contribution in this huge 5G technology? Because I find a lot of application in IoT, which is of this semiconductor devices, but as a wireless communication engineer in physical layer, where we can contribute. In the upcoming 5G and 6G technologies.
Yeah, fine. You know, IoT, for IoT at present, it is very to define our own protocol, first of all. So you need to identify the appropriate controllers. Okay, first of all, for development of IoT scenario, I'm just giving you the various options. So you have to now see in the implementation point of view, there are so many processors and controller systems which are under the development. And like just I'm giving you one example that Linkit one processor is there. Yeah, Node MCU is there. Apart from our conventional Raspberry Pi and all. And now Amoeba Realtek has developed the protocols, processors for, of course, with the protocols. Processors they have developed for real-time, what you can say, for the mission critical IoT services. So being an electronics engineer now one thing, there is no boundary between the electronics and computer engineer nowadays. So you have to learn the JSON format things, and you have to implement the sensors. Seeing the appropriate sensors and the appropriate processes. That is one thing. Second thing is, if you want to develop waveforms, the role of electronics engineer comes, or other engineers comes, like looking to the new channel. If you are willing to add the artificial intelligence or even artificial intelligence estimation and many other aspects are possible to develop. If you see the new module of MATLAB, it supports the 5G scenario. You will find many new channel models. Okay, CTP model and 3D models are there. So they are actually now used for the vehicular ad hoc network rather than conventional relay and Russian channel models. Plus, we have very good supportive environments like SDN, in which, supporting environment for SDN, that is STNet and MiniNet. So these are possibles for development of vehicular networks, and above that, establishing the SDN controls. Even in NetSeam, they have added many modules on 5G and VANET, so you can use those modules and develop your own protocols. Of course, they are providing the support for development of your own code by assuming certain. So, there are so many ways the electronics engineer can play the important role. It's very difficult to establish the resources for the testing purpose, but still up to significant extent it is possible now because institute support and the project funding supports are provided.
Yeah,
Okay,
thank
ma'am.
you, ma'am.
My answer is
Yeah,
yeah.
thank you, ma'am. And what about the
Okay,
source we need for terahertz frequency generation? Because as we know, for that much higher frequency, the sources are not available.
Yeah, it's very difficult at this moment. But you know, I am working with one fellow in Spain. They are actually working on the graphene surface based millimeter wave communication scenario. So sometimes by collaboration only it's possible. Otherwise, very difficult to generate some this kind of resources. But I think it's not impossible. Once you establish the setup, I think it will be the I mean, good revolution. It's
Okay,
very
ma'am.
difficult to develop such resources. Yeah, of course.
Okay, ma'am. There is another question is there. If the junctions
Yeah.
become more
Mhm.
traffic, how we can estimate the vehicle traffic? So in the chat box you can see also there are two
Yeah.
questions is there.
Yes. Okay. So if I would like to answer this question, first of all, I will say that traffic pattern analysis is one typical domain which is actually getting more popularity. So, traffic pattern analysis, sensing of traffic, and the intelligent decision making. These three you have to combine. So you need a lot of statistical approaches. You need a lot of previous databases, and based on that, because you know when the infrastructure is fixed, the there are again this question might be related to data traffic only. I hope, or if it is related to vehicle traffic, then also the solution will be different. So traffic pattern analysis, I told you that is regarding the data traffic. If the vehicular traffic patterns are to be analyzed, then the infrastructures are fixed. And if the videos are captured and the network is trained on the basis of that, you can have the intelligent decision making. So database traffic analysis is one thing. Vehicular traffic analysis is a different thing. That is the intelligent transportation system, you can say. So in both the cases, traffic pattern will play very important role. If you build your system like that, if you do the analysis, if you create the big data for that and take the intelligent decision making by adding artificial intelligence, I think it will be a better solution. I hope
No, ma'am.
my answer is yeah.
Ma'am, there is another question is there. How do
Hmm.
you correlated big data analysis with respect to bandwidth?
Big data analytics is a different thing. Uh, you know, now again, it is related to your real-time decision making and non-real-time decision making. Suppose your data analytics or big data handling is non-real-time requirement, then there is no question of bandwidth at all. If it is a non-real-time requirement, suppose you have already established a system, you have lot of previous data, you have lot of for decision making, then in the real time, if you have some sensed information, immediately on the basis of my previous patterns and the previous data, I can take the decision making. So then there is no question of bandwidth. Of course, if it is real-time decision making, definitely this big data analytics may not be the part of that decision making. Then the other approaches are required. So I don't think that this Because we have already seen so many protocols and the requirements of the bandwidths. I particularly selected some of the parameters, include numerical values, so that you can have the idea. So I don't think that you have any system which has the requirement of bandwidth beyond 20 megahertz. And that's what we are using in Wi-Fi. 5 hertz to 20 megahertz channelization. So, I mean, whatever may be the system, you don't have very large bandwidth requirement with reference to big data analytics requirement. So, of course, your question is a general question, but I can answer it in a different ways, like as I told you, real or non-real time requirements and instantaneous decision making requirement. Okay, so you can take it in appropriate way.